All right, so we left off here, and we are going to be working on the update. So now, the way that we want to do this is we don't just want to call the draw function. What we're going to do is every time we animate, we're going to call the update function. All right, now nothing appeared. Don't worry, because we are going to update the values, and then we're going to be calling the draw function with these new values. All right, so we're going to pass an object here called last point, and basically this is going to be passed on. So we're going to create this object, this value here. We're going to say last point equals what? Well, it's going to equal this dot x, or the x value is going to equal this dot x, and the y value is going to equal this dot y. All right, and let's make it look presentable or clean. All right, and then what we're going to do here is we're going to go ahead and change the value. So we've stored what the last point was, what the last value was. So now we're going to update the values for the particle. This dot x is going to equal its current position plus this dot dx, the rate of change, and then this dot y is going to plus equal this dot dy, and we'll let that go for now. So we'll just leave it at that. So we want it to change, right? Now we passed in this last point here. So this is in this dot update. So we did that, and we just want to call this dot draw for now. All right, so we could already see that it's constantly moving. Looks really trippy, doesn't it? But what's with this? This is very different than what we're seeing in the previous one. We see individual particles. Well, that's because in the animate function, basically we're continuously redrawing on the canvas without deleting what was drawn before. If we want to create the illusion of movement, we have to remove what was previously there. So what we're going to do is in the animation frame, we're going to go ctx.clear_rect. So before we draw anything, and so we're going to go from 0, 0 to ctx.canvas.width and ctx.canvas.height. And so now what we get is, you see that now we have bubbles. Now we have the circles. So we don't have the lines being drawn. We just have the kind of circular things going on, I guess you could say. Right? So cool. So we're making good progress here. But now they're gone. We don't see them anymore. We're going to address that. But before we do that, we need to... Oh, I'm losing myself. We need to... No, let's address this. Okay. This dot check bounds. We need to set up the initialization function. Right? So how and when do we reinitialize it? So first off, I want this to stay random. So we're going to go this dot radius. So once this passes, it leaves the screen. When it gets reinitialized, where do I want it to be? Well, I want it to have a random radius. I could just keep the same radius, but I want to have a random radius. So I'm going to basically call the exact same thing here. And this is the benefit of declaring these things globally, is that I could have access to them in the particle objects, or in the particle class. But that's when this is instantiated. The next one is I want to say that this dot x, so the x position of it, is going to equal a random value between the radius, between this dot r and ctx.canvas.width minus this dot r. And then this dot y should always equal, I want it to start off outside of the canvas so it looks like it's flowing down. So I'm going to say -50. So it should be, appearing above. You wouldn't be able to see it. All right, and then the other thing we need to do is we need to set the last point. So basically this is getting past the last point continuous. This is getting past the last point as well, and we're just going to set the last point when it's reinitialized is going to equal this dot x, and the last point dot y is going to equal this dot y. And yeah, we're good on that for now. Is dot y. And finally, we have to draw. We want to draw it again. We're going to go, and we're going to pass in last point. All right. Now, when does this get called? We have to test it. Well, it gets called when we check the bounds. So when we check the bounds, we are basically setting a conditional, and we're saying if this dot y is greater than, so it's off the screen, it's greater than ctx dot canvas dot height plus it's completely off the screen. Or I'll show you it without that. All right, so if it's just any part of it is off the screen, or the y is off the screen, not the radius included, we're going to end up with, we're going to call the function this dot init, and we're going to pass last point to it. But this hasn't been passed last point. Well, we're going to make sure that it does get last point. All right, and so in the update function, we are going to be checking the bounds. And once the bounds are checked, that's when they get drawn. That's when we draw. So we're going to remove this dot draw from the update function, and instead we're going to replace it with this dot check bounds. Right, and we're going to pass in last point to it. And here, if it's not, then we're just going to draw as normal. And we're going to pass in last point. Now right now last point isn't doing anything, but we see we're drawing. And once, as you can see now, they're getting reinstantiated at the top. So we're slowly getting there, right? Here's the thing. With this, as I was saying before, is that you can see that it's popping before they're fully off the screen. Well, that's because we're not including the radius in this calculation for the check. So we're saying if this dot y is greater than ctx.canvas.height, but it shouldn't just be ctx.canvas.height, it should be ctx.canvas.height plus this dot r. And so now these particles are moving completely off the screen before actually reinitializing, before passing this conditional and then reinitializing. All right, so we're slowly making progress. Cool. This is good stuff. So next, what we're going to do is we need to write the other boundary. Well, what's the other boundary? So currently, this works, but we want to add another conditional. And what's that conditional? Well, it's this dot L. I don't know if you remember, but in this animation, these guys are constantly fading out. They're slowly fading, and when they fade away, when their life is finished, you can't see them anymore, we want to reinitialize them. So we want this to take place here as well. How do we do this? We say, or this dot L is less than or equal to 0. Now right now that's not actually going to do anything because currently we're not updating the life parameter, the L, right? We're not updating it in here. Well, what if we do that? What if we say that we're displaying it here, but what if we say that this dot L in the update ends up decreasing, right? Because that's what we want. We want it to constantly decrease. So what does that look like? Well, we could say this dot L minus equals 0.01. We want it to slowly transition, multiplied by, this is hypothetically running at 60 frames per second. So we want that to be in consideration. So every second we want it to go down by 0.01, hypothetically. This may not be exact, it may not change exactly. So this is slowly coming along. Let's change the CSS so that we could actually see what's going on. Let's get rid of this background here on the canvas. And I do not want this body to be pink. That is gross. It's hard to see. And the white, they're fading. They're definitely fading. It's still hard to see. So what I'll do, well, here's the issue. I'm not reinitializing the L parameter, right? They're falling off screen. Now it's just a blank screen. So we need to do that as well. So let's go this dot R. Let's go here. This dot L is going to equal a random value between particle life dot min and particle life dot max. So you see that we're reusing this stuff. So what we should see now is they're reinstantiating, and they should be slowly fading away as well. We know that they are changing, but is it noticeable enough? That is the question. We got to find one. That one's disappearing. It's invisible. And it should be reinstantiating when it disappears. Can I prove that it's actually doing that? Yeah, definitely. Here's how. Let's remove this, and we'll say that only when it disappears will it reinstantiate, whatever you want to call it. I kind of change up between the two. So it's flowing. The only time we're going to have another particle appear up here is if its color fades completely. And they are fading, and that's why we're having this, because there's no check for when it actually leaves the canvas's length. All right, so we're gonna put that back. Cool, so next we are going to apply this last point.